They can be used interchangeably. They're all different ways to represent floating point numbers or fractional numbers. So a fixed, half, and float just represent different precisions of a fractional number. Right. So we have points, we have our point size. That should be good. Note that we don't actually need to expose either of these up here. These properties are just used to expose it to Unity. They're not used internally. All that is happening here is providing a nice thing for the material editor to actually be like, oh, there's a color defined inside of here that we need to use. Here is providing a nice thing for the material editor to actually be like, oh, there's a color defined inside of here that we need to use. That's all that's doing. So let's grab our point color, and then we should just be able to modify our albedo based on proximity to that point color, which means we're going to need a world position. And we need the world position because we're going to turn it into an object position. Actually, thinking about this a little more, we may not need to do that. No, yeah, we will. Sorry. So I'm going to take the world position here, but we're actually going to be translating this into our object position. We'll change that later. It actually might be worth it to do that in like a vertex shader, because then we only do this once per vertex instead of once per fragment. But we can optimize that later if we need to. I'm actually going to leave it just at the world position for now. So this is not done, but we can optimize that later if we need to. I'm actually going to leave it just as a world position for now. So this is not done, but the idea here is this way we can actually test. It won't change anything, it'll just change the space we're working in. So all the points that we would specify would have to be defined in world space and not in object space. So let's see here. Next thing, we're writing out our color to the albedo. Do we want to do that as more? Do we want to change the albedo, or do we want to change the emissive? I think it would be cooler if we change this and say make this a fixed interval of 0, 0, 0, and 1. So it's just not transparent, but it always is black. So it's not emissive initially, but then we're just going to write a simple for loop. So I is less than our point size, and then we just increment I. So standard for loop stuff. Normally control structures or like these kind of things aren't great in shaders. Usually you don't want like branching things, which a for loop or any kind of loop or if statements or anything like that. Those are all branching control things. And shaders typically, graphics cards in general, just don't really handle those as well. So that's sort of an obstacle, but it shouldn't be a problem here. We're not going to be destroying this in any amount of sense. So let's just add. Yeah, this will work. So what I want to do is add on the color. Do I even need that? Okay, this can actually not be a thing. Sorry. We can just make this a fixed thing and set it equal to 0. That's it. That's all we need to do. And then we want the max of 0 and then some calculation. And the reason we don't need that is because we're just having one emissive color. So I can do this dot emission equals the emissive times the point color, which will just multiply that color in at the end. So we don't actually need to keep modifying all 4 values. We can just do that later. Then Let's do a distance check. So we want to check the distance from every point. So we're going to do points I. Let's see if I remember how to get the length or the distance between 2 points. I think it's just this. And then it would be the input.world position. I hope. And we're going to, if we do 1 minus the length, if it's exactly on, it will just be 1. But then this will scale it down until it hits 0 at 1 distance, when it would become invisible. So that will give us a one unit of range for this to actually kind of show up. I think that kind of makes a little bit of sense. It'll be a linear fall off too, so it should just linearly go away. Unexpected bracket. Don't say that. I don't want there to be an unexpected bracket. What? What? Well, this is awkward. X, Y, Z, because we need to compare 2 3-point throws. So the thing is we're getting an error that there's a bracket at line 35. Oh, it's saying this is wrong. Oh, ha, he, ha, got it. So that's not actually, that's all C sharp stuff. We're doing more of a C style thing. So let's kind of define it there. We may need to give it a size, but I'm not going to. Unexpected token, square, get curly bracket at line 51. Oh, ha. Semicolon. Got it. Cool. Making all the mistakes. Unable to find an overloaded function of length. So we can't compare the length of 2 vectors? I guess it's not called that. This is going really well. Let's try distance? Sure. That's the next one we can try. I guess that worked. This is going well. I'm quite pleased that this is a massive disaster. But okay. No size for unsized array. So we do need to define a size, and it does give us an error. That's nice. So maximum points. Let's give it 50. So we can have as many as 50 points in there. And then after 50, it kind of it gets a little bit much. But with that, let's actually create our shield. So the thing is we're getting an error that there's a bracket at line 35. Oh, it's saying this is wrong. Oh, ha. Ha, got it. So, that's not actually, that's all C sharp stuff. We're doing more of a C style thing. So let's kind of define it there. We may need to give it a size, but I'm not going to. Unexpected token, curly bracket, at line 51. Oh, ha. Semicolon. Got it. Cool. Making all the mistakes. Unable to find no hood functional length. So you can't compare the length of two vectors? I guess it's not called that. This is going really well. Let's try distance? Sure. That's the next one we can try. I guess that worked. This is going well. I'm quite pleased that this is a massive disaster. But okay. No size for unsized array. So we do need to define a size, and it does give us an error. That's nice. So maximum points, let's give it 50. So we can have as many as 50 points in there, and then after 50 it kind of it gets a little bit much. But with that, let's actually create our shield. With that, let's actually create our shield and assign our material or our shader to that. Drop that on our sphere. I have no idea if that and assign. this execute in edit mode. This way. We'll actually be able to play around with things in the editor without having to deal with all of their fun stuff. Well, I broke it here. Alright, cool. That was a massive success, I guess. Cool thing. 0, 0. Good news. Our example here is kind of small, but it actually worked. So if I move this here, you'll see it's actually glowing red. Remember that we made this an emissive channel, so it won't change the color. But if I move it here, you can actually see red there. And red, so effectively the red is just following the center of our map, which is exactly what we would expect with world. Coordinates, world space coordinates. So let's put that at 1 here. You'll see it's actually glowing red. Remember that we made this an emissive. Let's try distance. Sure, that's the next one we can try. I guess that worked. This is going well. I'm here without having good news. Oh shit! Let's give it 50, so we can have as many as 50. This way we'll actually be able to play all these things in the editor without having to deal with all the waveform stuff. Let's go. I broke it. Alright, cool. That was it. I broke it. Let's go with these in this execute. Oh, ha. Semicolon. Got it. Cool. Making all the mistakes. Unable to find an overloaded function of length. Call that. This is going really well. Let's try curly bracket at line 51. Oh, ha. Semicolon. Got it. Cool. Making all the mistakes. Unable to find an overloaded function of length. You can't compare the length of two vectors? I guess it's not called that. This is going really well. Let's try distance. Sure, that's the next one we can try. I guess that works. This is going well. I'm quite pleased that this is a massive disaster. But okay, no size for unsized array. So we do need to define the size, and it does give us an error. That's nice. So maximum points. Let's give it 50. So we can have as many as 50 points in there. And then after 50, it kind of it gets a little bit much. But with that, let's this is zeroed now, when we convert this to object space, I expect to be able to rotate this. And so since this is zeroed now, when we convert this to object space, I expect to be able to rotate this sphere and for this color to stay in place. If that isn't happening, then it's not working. So that is the next thing we want to do. For that, we really just need to change this value. We need this input world space and for this color to stay in place. If that isn't happening, then it's not working. So that is the next thing we want to do. For that, we really just need to change this value. We need this input world space. I'm going to smack my mic a bunch, but we're going to change this input world space position to be in object color to stay in place. If that isn't happening, then to be in object space. And so there is a multiplication thing for that, which is something. Yes, it is definitely something. Let's do object position. Sure. And that's going to be a multiplication of world to object and the input world position. I think that's right. Unity. New functions for this, so it might actually, once it compiles, it might change this. Or it'll do that, whatever that was, that's now entirely white and our shadows are gone. Zero-sized array is not allowed, but we get rid of that. Ambiguous overload function reference. I think it wants it to be a 4-dimensional thing. I'm not entirely sure that error is not totally clear, but also I think it wants this to be in 4 dimensions, so we can actually just add on a 0 at the end. And that should take the X, Y, and Z from the world position. Just totally blow up in the face. Well, yep, okay. Float 4 needs to convert to that. XYZ, cool. Cannot implicitly convert from float 3 to float 4. probably because that world position is expected to be a float 3. So back to float 4. Cool. Let's add the 0 at the end. I think we need another parenthesis. Did I get them? I don't think I did. I feel like we're missing one. There we go. Cool. Got it. So, that should cover that. We're still getting those errors. Let me recompile this. The easiest way I know is just to save it again. We'll get some different errors. Ambiguous overload function. Huh. Well, that's interesting. I don't exactly know what is going on, why this is not working. Because we should be multiplying and Unity seems to be dropping my float 4. That's nice. I may need to go and look this up because this is definitely not going quickly. Yeah. Okay. I'm gonna be right back. I'm gonna go figure out what to do here. I think it's something simple that I'm missing, but we can figure that out. So, one moment, please. Okay, permission to be confused. This works now, and I don't know why it works now and didn't work before. Because we tried this, right? I did this. I thought I could have sworn this is what I did, right? I haven't gone back, but I'm pretty sure. Do is actually make it so it was multiplying a 4x4 matrix, which is what this is, and multiplying that by a 4-dimensional vector, which is that guy. And then we can actually just take the x, y, and z components out of that. We don't need the w component. So I should just be able to do that. And it works, I swear. Okay, good. It's still working. And then I can actually rotate it, and you'll see that the red actually stays aligned with the rotation of the object and not just, so we should just be able to do that. Dimensional vector, which is that guy. And then we can actually just take the x, y, and z components out of it. We don't need the w component. So we should just be able to do that. It works, I swear. Okay, good. It's still working. how to get things into object space, kind of get this glow going. And so the next step, at least there's a number, just take the X, Y, just go with that the red actually stays aligned with the rotation of the object and not just going right. So everything is actually doing what I said it would do. Which is a nice challenge. That doesn't always happen. So that's pretty much how to get things into object space and kind of get this glow going. And so the next step, at least there's a number of ways we can do it. First, we can add like some ring lighting, so it kind of glows around the outside. I always think that looks really cool on these kind of shaders. We can also add like refraction, so it bends the light in the grab. Connect can be the thing, maybe with that light, and that should be it. But we're gonna leave it here for now because this is. If you guys have any alteration, position, moving. We're going to make that fourth component in our vector a 1, which is, I'm going to totally screw this up because I'm just totally speaking from like 2 years previous experience. Hegemony, homogeneous, but making a vector homogeneous, which is going to actually allow it to be affected. So when it's 0, that means rotation will affect it, but positioning does not. Translations do not necessarily. By adding that 1, both of them should work. So, there we go. Totally caught that before posting it to the world. Definitely a thing that fixes it and actually makes it do the thing that I said that it did. So, that's it. Yep, it works now. Bye, I guess? Yep, bye.
Do you want to learn all the skills and techniques you need to create incredible designs? Do you want to know the process of how to create logos and brand?
Udemy は世界最大
Do you want to learn to draw
Hey everybody!
ビザビで伸ばそう。
Quote 5. Hello Internet, welcome back to our shield shader. Well, it's a little bit more than a shader. In this video, we are going to be adding some impact waves. Effectively the idea here is we are going to add a sawtooth wave onto the impact and then actually take advantage of this 4th number here to actually indicate the age of each impact. So it'll grow from 0 to 1 and then after that it will just disappear. So it'll represent the time and then we can represent that in various ways to actually show how it should actually disintegrate or act on this. So that's going to require some changes to the shield controller, and we're also going to be adding another component to actually create these impacts because we want them to appear and then expire as well. So that's what we're going to be working on. I think the first bit we want to do is actually going to be to modify the shader, which looks like this. This is picking up exactly where we left off with our previous video, the one where we were sending arrays into this shader. So what we're going to be doing is actually changing two things, I think. I think first we can probably drop the metallic and glossiness settings. We're not going to be using them, so might as well just reuse them for something useful. So I will get rid of those, and we can just set them to 0 for now. That should be fine. So this is going to be our impact size. Yeah. And so this is going to be a float, and it's going to represent the size of the impact at the maximum time. So at 0, the impact size is 0, and then over the course of its lifespan, it is going to grow to whatever size we specify here. Size is 0, and then over the course of its lifespan, it is going to grow to whatever size we specify here. So it's just a linear progression. I think linear is probably the easiest one for what we're doing now. We can obviously go back and change that if we need to, but it just makes the most sense here. So we're going to expose that down below, and then we need to actually access that. So, how do we do that? Where do we get our position, or our points? There we go, okay. This. What we need to change, we're taking the distance and subtracting it from this 1. Instead of doing that, we're going to take the points W vector, or W, W coordinate, and we are going to multiply that by our point size, not our point size, by our impact size. And so previously 1 was giving our points that size of 1. Now that we have this, what should happen is it should go away. Because, well, is that what I expected? Ah, yes. Because our sphere is 0.5. So if I do 0.5, that should be right on the outside. And then like 0.1. 1. Now that we have this, what should you see W coordinate, and we are going to multiply that by our point size, not our point size, by our impact size. And so previously 1 was giving our points that size of 1. Now that we have this, what should happen is it should go away. Because, well, is that what I expected? Ah, yes. Because our sphere is 0.5. If I do 0.5, that should be right on the outside. And then like 0.1. Over the course of its lifespan, it is going to grow to whatever size we specify here. So it's just a linear progression, and I think linear is probably the easiest one but it just makes the most sense. So we're going to expose that down below, and then we need to actually access that. So how do we do that? Where do we get our... There we go. And then, so we're going to expose that down below. And then, you need to actually access that. So, how do we do that? Where do we get our position or our points? There we go. Okay. This. What we need to change, we're taking the distance and subtracting it from this 1. Instead of doing that, we're going to take the points W coordinate, and we are going to multiply that by our point size. Not our point size, by our impact size. And so previously one was giving our points that size of bit we want to do is actually going to be to modify the shader, which looks like this. This is the picking up exactly where we left sending. What we're going to be doing is actually changing 2 things, I think. Settings, we're not going to be using them, so might as well just reuse them for something useful. So I will get rid of those. And we can just set them to 0 for now. That should be fine. So, this is going to be our... reuse them for something useful. So I will get rid of those. And we can just set them to 0 for now. That should be fine. So, this is going to be our impact size. Yeah. And so this is going to be a float, and it's going to represent the size of the impact at the maximum time. So at 0, the impact size is 0, and then over the course of its lifespan, it is going to grow to whatever size we specify here. So it's just a linear progression, and I think linear is probably the easiest one for what we're doing now. We can obviously go back and change that if we need to, but it just makes the most sense here. So we're going to expose that down below, and then we need to actually access that. So how do we do that? Where do we get our position or our points? There we go. Okay. This. What we need to change, we're taking the distance and subtracting it from this 1. Instead of doing that, we're going to take the points W vector, or W W coordinate, and we are going to multiply that by our point size, not our point size, by our impact size. And so previously 1 was giving our points that size of 1. Now that we have this, what should happen is it should go away. Because, well, is that what I expected? It should go away. Because, well, is that what I expected? Ah, yes. Because our sphere is 0.5. So if I do 0.5, that should be right on the outside. Give us just a little bit of red right there. And then as we grow this, you can see it expand. And so this gives us a way to kind of fine tune the size of this. And if we want to change this a little bit more, what we can do is actually divide this size. Is this a good way? Yeah. This will work. Divide this size by the impact size. I'm considering if I want to do this. This will have a different effect than we may want. But what it means is like 0.1 should be I'm considering if I want to do this. This will have a different effect than we may want. But what it means is like 0.1 should be a little bit more pronounced because it will be multiplied there. And so we should get stronger colors initially. And then as I move this out, it will slowly, once we get to numbers bigger than 1, the actual effect is lessened slightly. You won't really notice it here just because of the size of things, but hopefully it's a little bit apparent. Yeah, not really. So, that's that. Effectively, all it's doing, 5W value becomes fantastic. Now, we have some hard... I guess it's not so much hard. I want this to be a... What's the word for it? I want this to be a saw wave, so there's 3 types of like standard waves. There's the classic like sine wave, which is just ups and downs. Then there's the saw wave, which is a spike with like a linear progression down or up. It can go in either way. And then there's the square wave, and that is kind of like spikes up and then spikes down. I'll put a picture here. This is a call out to editing me. Put in picture. Anyway, so those are the standard types of waves. I'm thinking it makes sense to have the most energy at the outside and kind of go out and then leave like a little trail. And we can do that with a saw. So we're gonna do a fraction of 1 minus that. Is this what I want? Divided by the... I think this should work. Yeah, so I just want to invert this. Whoops. Ambiguous overload for a int, because I didn't mean to use an int there. Cool. That is not even close to what I wanted. Okay, it actually is. So, add there. Ambiguous overload for a int, because I didn't mean to use an int there. Divided by the... I think this should work. Yeah, progression down. Let's be quick. There's a point. I want this. There's that extra little. Because I didn't need. there's an int there. Cool. That is not even close to what I wanted. Because we want them to appear and then expire. I think with our previous video, the one where we were sending arrays into this shader. So what we're going to be doing is actually changing two things. I can probably we're not getting, so I will get rid of those, and we can just set them to 0 for now. That should be fine. So this is going to be our impact size. Yeah. And so this is going to be a float, and it's going to represent the size of the impact. It is linear progression grow. 2 is probably the easiest one for what makes the most sense here. And then we need to actually we're taking that vector or W coordinate, and we are going to multiply that by our point size. Not our point size, by our impact size. And so previously 1 was giving our points that size of 1. Now that we have this, what should happen is it should go away. Here, should that size of 1. Now that we have this, what should happen, size of 1. Now that we expected? Ah, yes. Because our sphere is .5. So if I do 0.5, that should be right on the outside. And then like 0.1 should give us just a little bit of red right there. And then as we grow this, you can see it expand. And so this gives us a way to kind of fine tune the size of this. And if we want to change this a little bit more, what we can do is actually divide this size. Is this a good way? Yeah, this will work. Divide this size by the impact size. I'm considering if I want to do this. This will have a different effect than we may want. But what it means is like 0.1. Should be a little bit more pronounced as I first bigger left. Now we have some this classic, which is empty, but this should work. That is close to. I didn't mean to use an ink there. Cool. That is not even close to what I wanted. Okay, it actually is. So, that's where we're going to need that division, but you can actually see if I increase it. We actually get these like hard lines and then they grow and fade out. So that's sort of what we want, but not really like this. So instead, we should be able to, if I'm correct here, plug in the impact size as the other thing we're taking the fraction of. Dang. So let's divide this by the impact size. So what that's going to do is divide our maximum by the impact size. So hopefully it grows a little bit. I want to drop this down to like 0.25, so we should have a period of 0.25 units, which should mean we should get 2 waves per iteration. So if I drop this to like 3-ish, it looks fairly close. I know that annoys people when I kind of like zoom around like that, but that's almost there. It's pretty close, and so that I'm happy with. We can probably validate that it's exactly what we want. I don't know. It accomplishes the effect that I want, so I'm not particularly picky. So, now that we have that, what we can also do... There. It's pretty close. And so that I'm happy with. We can probably validate that it's exactly what we want. I don't know. It accomplishes the effect that I want, so I'm not particularly picky. So, now that we have that, what we can also do is... Do I want to do this? Yeah. Multiply the emissive strength by our... Ooh, not like that. But I want to take this fraction that we have and multiply it by the points I.W. So effectively we're going to make it fade out over time. It's going to be a linear fade. So that is not a linear fade. Oh. That's because W is equal to 6. We want it equal to... Oh! Ha! Ha! That's wrong. Let's do this. 1 minus that. So the time is going to go from 0 to 1. And so we want it to be 0 when it's at the maximum time. So there'll be a linear progression to that fading out. And so as this grows towards 0, it fades out. It goes blue, but that we don't care about that because we're not going to actually run into that case. But that's just the math being blue. So effectively, that's sort of the impact we're going to get is going to be a hit, and then it's going to spread out and go dark. And so we can increase the size of the hit by increasing the smoothness. And we can probably, if we want, we can actually add like some padding so we actually get the wave to go out. I kind of like the way this looks, so we'll probably stick with that for now. If you guys want to see a way to change that, or either come up with it yourself and kind of play around, it'd be a good excuse to do that, or we can look into it in another video. But this should be fine for now. So bang, you get hit, and then it like flashes out. So I think that's probably good for the shader. That should cover everything that we need to get done there. So I'm actually, just to test this and make sure we actually have the sum working correctly. Stick with that for now. If you guys want to see a way to change that, or either come up with it yourself and kind of play around, it'd be a good excuse to do that, or you can look into it in another video. But this should be fine for now. So bang, you get hit, and then it like flashes out. So I think that's probably good for the shader. That should cover everything that we need to get done there. So I'm actually, just to test this and make sure we actually have the sum working. Correctly. Let's do 0.33. So effectively a third of everything. I see nothing. Oh, wait, no, that should be correct. We may need to go on a bug hunt. Also, I'm going to delete the directional light. That'll make it way easier to tell. I see nothing. Oh, wait, no, that should be correct. We may need to go on a bug hunt. Also, I'm going to delete the directional light. That'll make it way easier to tell. where our impacts are. Yeah, this doesn't seem right to me. This doesn't seem right at all. We should have, so, what's just to make sure I'm not going insane. That should work. It should be on the back now. Or, yeah. So I would expect a red dot on the back, and we're not getting that. So I don't think this works. Why not? We sum up our emission. And then do everything else. I don't think it's anything we just did. We actually never tested this. So I'm curious what might be causing it. Because this. So I'm curious what might be causing it. Because so it could be a whole bunch of things, unfortunately. We don't care about the projectile thing can go away. The point render can go away. That's all other stuff. And why doesn't it work? I don't know. Shader has there. Just I would need bits. Well, would actually do this? I know this, but 0 and put these, and we do something to shade in that. It's actually this work able to back and have getting way out to another. I know this function is getting way out of hand. Let's do another. I know this function is getting way out of hand. But just for my own sanity, I want to stop it from ever becoming 0. Let's do. Another. I know this function is getting way out of hand. But just for my own sanity, I want to stop it from ever becoming 0 or less than. There we go. So that must have been what was happening. We had some math that was causing it to cancel out, and so whatever our fraction was making it 0. So it's back now. Awesome. Which is why we didn't see that previously. So if we put these near one another, we should be able to see them add together, and we do. So, this works. Now, I want to write something to test this. So we're actually going to animate this shader a little bit, and make something that will actually create these points, and then age them. So, what's a good way to do that? We cannot, it's actually, this works. Now, I want to write something to test this. So we're actually going to animate this shader a little bit and make something that will actually create these points and then age them. So, what's a good way to do that? We cannot, it's actually a error in the shader if you set the array to have 0 indexes, so it's not possible for it to have no elements. So we're actually going to do a points dot if points dot length is less than or equal to 0, then do something otherwise, do the normal thing. So what we're going to actually end up doing is say set vector array, and this is going to be a little bit gross-ish, but we're actually just going to set it to a new vector 4 array. Is that a good idea? No, let's do a private static read-only. Default empty vector, and we'll create a new vector 4 array here with just one element, which will be a new vector 4 of say 0, 0, 0, 0, and that shouldn't be a problem there because the count itself is going to be 0, so it's not actually going to draw that ever. It's just to avoid any shader errors, which you in your code that you're actually going to be using. So this way we can just use the default empty vector whenever there's an issue. And I think that handles that fairly cleanly. I don't know if there's a better way to do that, but that should at least clean that error up. Which means we're going to use our test. Well, it's going to be fine. We're going to be generating way more. So this should load. Question mark? It's thinking about loading. Really thinking about it. I don't know why this takes so long. It's not... I've tested like antivirus. I've tested my hard drives. It's on a really fast SSD. So this shouldn't be a problem, but right. It's not even like the Cortana thinking ring. Let's set that to 0, and we don't get any errors, which previously we... we actually were, so this is good. Everything is fantastic. I don't want to save that yet. So, let's create a shield attack simulator. And so what this is going to do is literally just attack a shield. So we're going to do a public float radius, which is going to be the radius of the attack. We're attacking a sphere, so that just makes sense. And we also, what else do we need? Public float shots per second, and a public float. I'm going to handle every part of this in this simulator for now, and then we're just going to take the calculated result and copy it over to our controller. You could get into an argument about whether you want like the aging and stuff to happen on the controller or not, but that's going to be up to whatever project you're working on and how you want to handle that. So we're not going to really cover that. That's on you. That's your design choice. So what else do we need? We need the radius shots per second. We're going to need a private float timer and a private list. Let's do a linked list. So we're going to use a linked list here because we're going to be adding and removing things constantly, and linked lists are just better for that. They can handle those kind of inserts in constant-ish, not really constant time, I guess, because we're going to not necessarily be pulling things from the start, but anyway. They should be able to handle this better. But then we just need it to be a vector 4. And these will be our projectiles. And finally, we need our shield controller. And so what I'm going to do is at the very end here, we're going to take our controller dot points and set it equal to our projectiles dot to array. And I don't have link, do I? I hate that it does that. That's so annoying. That like that giant Windows beep, especially when I have my volume up because I was listening to music or whatever, and that goes off without other things. It gets really annoying. It gets your attention, I guess, but let's see here. Timer plus equals the time delta time, and then I'm actually going to do a while here because, well, we're going to do a while because if the timer is greater than, or if we're firing a lot of shots and they have a really short duration, it's possible for, at a slow frame rate, it's possible for multiple shots to occur in a single frame, and so we'd never actually catch up, or we'd just be behind. So actually if we do while timer is greater than the shots per second, or not shots per second, shot time, shot cooldown. The naming struggle is real. Alright. So, while the timer is greater than the shot cooldown, we're going to do timer minus equals the shot cooldown, and just subtract from that. This prevents us from getting any additional floating points, and it will also increase our accuracy. So if, for example, let's say we take 5 frames, or like 5-6 frames to actually count up to that, it's possible that it actually only took us like 5.5 frames to count up to that, and at that point we'd actually be losing like half of a frame every single shot. If we rolled it back to 0, like we could do, by doing that we actually lose time. These will be 8. And we also, Is that it does that. That's so annoying. That like that giant Windows beep, especially. That's so. I hate that it does that. That's so annoying. That like that giant Windows beep, especially when I have my volume up because I was listening to music or whatever. When that goes off, without other things, it gets really annoying. It gets your attention, I guess, but it's pretty shot. Equals second frame on a having like really not this, because we're gonna get a random on unit sphere, which is going to be a vector 3. So this is going to be the point that we're spawning it at, and I'm going to multiply this by the radius, just so we have that. And then part of the issue is then we have to actually turn that into a vector 4, because we need point x, point y, and point z, but we also need 0 for the initial time. And so that should capture our point, it should capture the time that we're going to send. And then the final bit that we need to actually send over, public float projectile life. Yeah, that makes sense. So what we're going to do is then for each projectile in our projectiles, we're actually going to increase their life, which this may not work. Projectiles that W plus equals time that delta time divided by our projectile life. So projectile life defines how many seconds it's going to stay alive. So if we do 5, we're counting from 0 to 1, so we actually want to divide by 5 and actually take a fifth of whatever the current time was, and that will actually get us up to 1 in 5 seconds. The problem we're running into is this is a struct, which means we can't modify it during a for each. That's not valid. What's a good way to do that? Is there a good way to do that? Not really. So, I mean, yeah, well, not really. I don't think this is valid. That's not gonna work. You can't do that. That's a really bad idea. Let's see here. So there's a number of ways we could do this, and I'm starting to think using a list might make more sense. So if I do vector 4 projectiles array, initialize that so projectiles equals a new vector 4 array of say 100. Is that a good idea? This seems like an even stupider idea. I'm trying to figure out a good way to handle the modifier to actually for the equal. Like I could literally just putting it in some of errors. construct. Besides putting it in some sort of container, which is possible. Like I could literally just